Okay, so first we start with something called your project cost duration graph. Okay, so here we will have cost in the x-axis and duration in the y-axis. Now, it is generally seen in projects that your as time increases, okay, as duration increases, your indirect cost also increases. And your direct costs are generally found to be decreasing as your time duration increases in any project. Now, if you sum up this direct and indirect cost, you will find your total cost of the project. Okay, it comes like this: something first it will decrease and then it will increase. So this is your total cost of the project. Okay, and at a point where you find that there is the lowest total cost, you will find this point. Okay, this is called your optimum cost time point. Optimum cost time point. Okay, so remember this graph whenever you do any uh, costing related numericals for your project management. Next, we have this activity graph. Okay. Now, here what you have is for a particular activity, let's say one activity you have, and here also if you plot your duration, this is your activity duration, and this is your activity cost. And let's say there is an activity A. Okay, so the cost of normal completion of this activity is let's say $400, and if you crash that activity, meaning if you want to complete that activity in a shorter duration of time, so let's say the cost is $800. Okay, and if your two time points are, let's say, 10 days and 5 days. Okay, so you'll have these points of intersection in the two for the normal cost and the crash cost. So let's say this is your normal cost. Okay, we'll write here, this is your normal cost, and this is your crash cost. Okay, and so you'll have these two time durations, that is your uh, crash duration, and this is your normal duration. Okay, so you'll have these 2 points, let's say points B and D. Okay, so if you draw a line here, this is your crash point, and this D is your normal point. Fine. So this slope B and D, this is your cost slope. Okay, this is called rise by run. So you can also write it as crash cost minus normal cost, okay, divided by your normal time minus crash time. You can write it with the first two letters of each of these words, cc minus nc, divided by nt minus ct. Okay, so from this graph, if we take the numbers, okay, so we get cc as 800 and nc as 400, okay, and normal time as your 5 into 10, and your crash time as 5. Okay, so we'll just write that here. This is equal to 800 minus 400 divided by 10 minus 5. So this is equal to 400 by 5 equal to $80 per unit of time. Okay, so we start with these basic understandings, and then we proceed with a numerical. Now we take the same numerical which we have solved in the class, okay, and here let's create a table which will have your activity ID, okay, predecessor, then we'll calculate the slope, we'll calculate the maximum crash time, and also we'll have the different costs and times. Okay, so these are all for direct costs. Let's say this is for the normal time and the normal cost, and this is for the crash time and the crash cost. So this will be time factor, and this will be the cost component. So again, time and cost. Okay, so let's make the table. So the different activities which we had taken are A, B, C, D, E, F, and G. So I need a few more spaces. For simplicity and for easy understanding, I'll just make few lines here as well. Okay, so the predecessor activity is given A, there is no predecessor activity, it's a dash. Okay, for B it is A, for C it is also A, for D it is also A, and for E it was B, for F it was C, and for G it was E. Okay, and it is given that A takes 3 units of time, cost is 50, and for B it is 6 and 80, 10 and 60, 11 and 50, 8 and 100, 5 and 40, 6 and 70. Okay. Now the crash time and crash costs are 2 and 70, 4 and 160. Okay. 9 and 90, 7 and 150, 6 and 160, 4 and 70, and 6 and 70. Okay, so this is the table that we have for your activity, predecessor, and different costs related to the direct costs. Okay, the normal time, crash cost, and normal cost. This is given. Okay, so based on this, now we will calculate the slope and maximum crash time. So how do we calculate this maximum crash time? It is this 3 minus 2. Simple. 3 minus 2. So we have maximum crash time as 1. Okay. 6 minus 4, we have it as 2. 10 minus 9, 1. 11 minus 7, 4. 8 minus 6, 2. 5 minus 4 is 1, and 6 minus 6 is 0. Okay, simply, it's very simple. So we calculate the maximum crash time. Now what we need to do is we need to calculate the slope. How do we do that? So it is 70 cc minus cc minus nc divided by nt minus ct, as we had done in the previous formula. This formula, as we had done in this formula, we'll use, okay, crash cost minus normal cost, normal time minus crash time, same thing. Okay, we'll use this. So it is 70 minus 50. Okay, 70 minus 50 is 20. 20 divided by 1, so we get 20. 160 minus 80, that is 80. 80 divided by 2 is 40. Okay. 90 minus 60, that is 30. 30 divided by 1, again 30. 150 minus 50, it is 100. 100 divided by 4, so we get it as 25. Okay. 160 minus 100, that is 60 divided by 2 is 30. 70 minus 40, again 30. 70 minus 70 is 0. Okay, so this is what we get: slope, the maximum crash time, and predecessor activities, which we already have. Okay, so let's first find out the network diagram of this entire project. So how does it look like? This we had done previously in the class. Okay, so we'll make the diagram. So A does not have any predecessor activity, so we'll start with A. So A, what is the time duration? It is 3. Okay, from this we'll take the normal time and cost. So A gets completed in 3 days, so we take it this way. Okay, next we have B. For B, if you look at the table, okay, I'll keep it like this. Fine. So we know B is 6 days. Okay, so from the table, just look at the table and we can make this. B is 6 days. C, if you look at the graph again, it is 10. So C, 10 days. Then we also have D. D, we have it as 11. Okay, and next we have E. So we'll write E here. Okay,